Hello friends, welcome to our live tutorial session on Python. So this is our seventh tutorial in live classes, and today we are going to talk about how to generate some of the basic signals. So when we talk about basic signal means it is like impulse signal, step signal or sine wave in Python. Okay. Further, we also provide online training, help in technical assignments. We also do freelance project based on data science, Python, machine learning, embedded system, etc. So if you have any such requirement, then you can let us know by contacting us through our website, which is www.jcbrolabs.org, or you can also mail us at info@jcbrolabs.org. Okay, so let's continue. In our last tutorial class, we talked about NumPy and Matplotlib, right? And we did some examples on plotting some normal graph or any polynomial graphs. So today we will continue in the same session or in the same series. We will be generating like impulse signal and step signal and sine wave in Python. So these signals are very basic in DSP and generally used for different kind of purposes. Okay, so let's continue uh, with the signals. Okay, so we will go to draw here. So basic signal generation. So you can generate any kind of the signal as long as you are familiar with its mathematical equation. So when we talk about basic signals, so first is like step impulse signal, not step unit impulse signal, right? So as we are dealing with the discrete time system, so all the signals which we will be dealing here will be of discrete time only, because computer is a discrete time system as well. So if we talk about from the time domain perspective, if it is a time, because when we are dealing with discrete, so it will become the sample number. So at sample number 0, the value is 1, and at all other samples, the value is 0. Okay. So mathematically, you can describe it like x of n is equals to 1 for n equals to 0 and 0 when n is not equals to 0. So this is a kind of a unit impulse signal. So first of all, we will generate this. Okay. So we'll go to the spider and then we will write a program for it. Okay. So first of all, we'll save this file in the same folder where we are saving all of our other files in Python, and here generate basic signal and then save it. Okay, so we will first import matplotlib.pyplot as plt, and then we will import numpy as np. Okay, so as we did earlier, first of all we'll close all the plots which have been opened. So plt.close. Now we will generate first of all, because we want to generate this this sample number. So first of all, we have to generate this sample numbers on which we want to plot the data, right? Because from our last class, there will be some x values, right? So some x values corresponding to which you will be computing the y values. Okay, so this is x-axis values and this is y-axis value. So right now on x-axis we have n, so we will generating these n values here. Okay, so there is a command n equals to np dot arrange. So we'll generate from -10 to 10, right? So I hope you remember this np dot arrange is a function we generate from in this range at a difference of 1. If we give like this, so it will generate by default at a difference of 1, and it goes from -10 to last index -1. So it will go from -10 to 9. Now we'll generate the values of x. Okay, so we'll generate some zeros values of x, right? So we will generate it like np dot zeros and then length of n, right? And then after that we will be doing, okay, so x and n are generated. So first of all, generate impulse signal, okay? And then we will be writing, we will finding where n equals to 0, because wherever n equals to 0, in order to generate the file, wherever n equals to 0 we have to put the value 1, right? So we will make n equals to 0. So we'll find that index at which n equals to 0. So n equals to 0, simple, and we'll make it 1. That's simple, right? And then we will plot. So we'll make a stem plot and so that it looks fine. And then plt.x label, we'll put it like sample number, and then plt.y label, we'll put it as amplitude. Okay, and then we can put the title as well, plt.title, and we'll make it something like yeah, impulse signal. Okay, let's save it. Now let's run it. Okay, so the plot is available. Let me show you. The plot is available here right now. Okay, now let's try to make the grid on. So we can also do the same by typing plt.grid and making on. So if I run it again, you will see impulse signal with grid. Okay, that's fine. Now the next signal which we are going to generate today is a step signal. So in the meantime, if any one of you have any doubt, then you can let us know by your comments or by typing the comments in this live chat. Okay. So going to the second signal which we are going to talk about today, that is to draw, yeah, that is unit step signal. Okay, so when we talk about a unit step signal, so this signal looks like this, and I hope you are familiar with the mathematical equation. For n equals to 0 to all the values which are greater than 0, it is 1, and for all values which are less than 0, it is 0. So we can mathematically write it like 1 if n is greater than or equals to 0, and 0 if n is less than 0. Okay, so again, first of all, now we'll do the simulation of the same. Now in the same file we'll do the simulation. So we have already generated the values of n, and x is also generated zeros. So what we'll do, okay, we will generate it again. Yeah. Generate step signal. Okay, now one more thing, as you have seen, we were generating the graph in a single one. So what we'll do, in the half part we'll generate impulse signal, and the lower half part will generate a step signal. Okay, so we'll again go to here. So we'll make it with a different name, y equals to np dot zeros length of n, right? And then we will make y where n is greater than or equals to 0. For all those index we want to make it 1. Okay, now coming to the plotting part. So we have to use subplot. So plt dot subplot 2 comma 1 comma 1, and here we'll type it like plt dot subplot 2 comma 1 comma 2, and then plt dot stem and comma y, and we'll type plt dot x label sample number, plt dot y label amplitude, and plt.title step signal, right? And then we'll make the grid on as well, plt.grid on. Save it and let's run it. Okay, so graph is visual. Okay, so this is the signal, but you will see, okay, these lines are overlapping to each other. So what we'll do, there's a command plt dot tight layout, tight underscore layout. So it separates all the layouts all within the graph. We will run it. Okay, you will see a nice and clean graph. First graph is showing the impulse signal and the second one is showing the step signal. Okay, so these are the two ways, like generating a simple impulse signal and then step signal using Python. Now we will jump to the next part, that is how to generate a sine wave in Matlab, in Python. Okay. So third part is sine wave. Now it is a little complex. The concept is little complex. Otherwise, it is very fine. The sine wave means we have to generate sine wave on any specific frequency, let's say 10 hertz, right? Now you have to follow me carefully. Now, as I said, like all things, whatever we are doing right now on the system or on computer, that is of discrete time system. So in discrete time system, everything is sample, right? So we cannot generate a continuous time signal which is like continuous in real terms on computer. So we have to generate some samples of it. Now in order to generate some samples, we need a sampling frequency, right? It is known as the sampling frequency. And if you have gone through some of the basics of DSP, you know the sampling frequency, the theorem, there is a sampling theorem which says like sampling frequency should be greater than or equals to twice of the signal frequency. I can say this f is the signal frequency. Okay, so this is the minimum requirement as per the sampling frequency theorem, right? Now here we are trying to generate a signal of 10 hertz. So from this formula, fs seems to be, that means it should be greater than of 20 hertz. Okay, so you can think of it as a threshold, but if you want to plot it, so in practical it should be some as I have observed personally, so you should have taken it 10 times of the signal frequency. Okay, if you are doing a simulation. Okay, so now one thing is sure, now when we are making it sampling frequency, first of all we have to specify the sampling frequency. So we'll take sampling frequency for being on safe side as 1000 hertz, and we'll be generating a frequency of 10 hertz. Now samples means let's say this is our sine wave. So this is one sample, second sample, third samples, and fourth sample, and so on. So if you look at it from this perspective, so this is a time instance, right? Time has been replaced by n of t. So this was 0. Now this is first t, this is 2t. So where t is 1 by fs, and it is known as the sampling interval, right? So the difference between the time difference between these two sample is known as the sampling interval. Now this is opposite to 1 by fs. Now if we talk about the sample number, so this is 0th sample number, this is first sample number, this is second sample number, and so on. So now there are two different things here. Now first is the sample number. If we talk about n, so it could be 0, 1, 2, 3, 4, 5. These are the sample number. Now if I multiply it with by t, that means 1 by fs, so it will become 0, it will become 1 by fs, it will become 2 by fs, it will become 3 by fs. So now these values will become time instant at which we are sampling it. So we will now when we are talking about plotting and putting the x level, so it depends like how you are making the x-axis. Okay, and that's everything we are going to see in when we are going to do the simulation. So now coming to the simulation part. Okay, so we'll make it generate sine wave. So we'll generate the sampling frequency. So as I said 1000 we are making it, and signal frequency of, let's say, 10 hertz, right? And then we will be generating the n index. So right now it is n, so we'll generate np dot arrange. Let's say we are generating 1000 samples of it, right? And then x, so x will become, now if you think about the sine equation, so x of n, it will become sine 2 pi f into nt, right? So this ts is the sampling interval. So this ts has been replaced by small t. So in time domain we have a small t, but when we have sampled it, it will become n into ts. So that's what we are going to use here. Okay, so it will become x equals to okay, np dot sine 2 into 3.14, let's say, and into f is the sampling frequency, then n, then now we have to make it fs, so we'll write n by fs. Now it will become time. Okay, instead of this time, let's say we are just doing it for the sample index, right? Okay, it will be n by fs, right? And now we will plot, because we want to plot on a different window, so we'll create a different window figure by this figure command. It will be second figure, and then plt dot plot will plot and comment. So remember we are plotting n versus x, right? So it is the sample number, so we'll type it plt dot x label samples. Right now we can specify, we cannot specify that whether it is a time in seconds or not, and plt dot y label as amplitude, and then plt dot title as step sine wave, right? Yeah, and plt dot grade. Okay, everything looks fine. Let's run it. Okay, you have seen a clear sine wave. So right now they are the samples here. Okay, now let's verify different things which I talked about, like about the sampling frequency. So as per the sampling theorem, this fs should be greater than 20, because 2 times of this 10. So let's make it 30 and let's save it. So if I run it again, okay, you will observe the wave has been distorted completely. Okay, it is following the sine wave, but it is not good. Yeah, if we make it to home. So let's zoom out a little bit. Yeah, it doesn't looks like a sine frequency of 10 hertz. Yes, it is following. Okay, now let's say if I just make it equals to 20, it will be totally different wave right now, like this. Okay, so that is why I was thinking to use generally 10 times. So it could be if I make it 100, generally it looks like something good. Okay, now the frequency is same, because overall we are changing the number of samples within the sampling frequency. So this is the wave. Now let's make it to time. So let's say we want to generate in time one. If I make it 1 by fs, so this n will become t. So right now we are generating the values from 0 to 1 second, and here we can specify it as n. Okay, so for 1 second, and here now we can specify time as seconds. Now let's run it. Okay, the same wave with 10 hertz frequency, right? And let's change it to 5. Okay, that's all wrong. Control Z, generate sine wave, and make it 500. The same sine wave, make it, let's say, 50. The same. So it is of 1 second. Earlier when we were taking the samples, everything was changing, right? And yeah, let's making it 30. So this is the best way to generate a sine wave. Okay, so let's make it 1000 only. Okay, so now you have seen like how to generate this sine wave, or how to generate this impulse signal, and all different kind of other signal in Python, and how to play with the different kind of variations. So if you are doing some simulation, then you can think of this trick, and you should know these basic concepts. So I hope that that's it for this video, and we will meet again with this live session after some time, okay, with some new topics. So till then, bye. Finally, we also provide online training, help in technical assignments. We also do freelance project based on data science, Python, machine learning, embedded system, etc. So if you have any such requirement, then you can let us know by contacting us through our website, which is www.jcbrolabs.org, or you can also mail us at info@jcbrolabs.org.